4. Today our lesson is Symmetrical Figures and Lines of Symmetry. To help you understand the meaning of symmetrical figures and line of symmetry, let's take a look into this figure, which is a heart. And imagine that we draw a line in the middle of it, which in turn will divide the heart into two parts. Also imagine that we fold this heart along this line. Then we will find that the two parts would exactly match and exactly are above each other. This line called line of symmetry, and the figure called symmetrical figure. And we say that the two parts are congruent. Congruent means that corresponding sides are equal in length and corresponding angles are equal in measure. Now, you may ask yourself, is every line that divides the shape into two congruent parts is a symmetrical line? To answer this question, let's take a look into a parallelogram. And imagine that we draw one of its diagonal, which will divide it into two congruent triangles. But if we fold it along this line, we will find that the two triangles are not exactly above each other. Thus, this line is not a line of symmetry. And we say that if there is a line which divides a figure into two congruent parts, it's not a must to be a line of symmetry of this figure. Again, not every line divides the shape into two congruent parts is a line of symmetry. Now, notice that some geometrical figures have one or more lines of symmetry. In this case, we call this figure symmetrical figures, where some figures have no line of symmetry, and in this case, we call this figure non-symmetrical figures. Now let's see the number of lines for some geometrical figures. Figures with one line of symmetry. Isosceles triangle has one vertical line of symmetry, and isosceles trapezium also has one line of symmetry. Figures with two lines of symmetry. Rhombus has two lines of symmetry. The two lines, actually it's two diagonals, one vertical and the other is horizontal. And rectangle also has two lines of symmetry, one vertical and the other is horizontal. Figures with three lines of symmetry. Equilateral triangle has three lines of symmetry, 1 and 2 and 3. Figures with four lines of symmetry. Square has two lines of symmetry, vertical and horizontal one, and the other two lines of symmetry are actually its diagonal. Figures with 6 lines of symmetry. It's the regular hexagon. Let's count it: 1 and 2 and 3, 4 and 5 and 6. About figures with no lines of symmetry: parallelogram, trapezium, and scalene triangle. Those figures have no lines of symmetry. Now let's take an example. In the opposite figure, A, B, C, D. The dashed line, the red one, is a line of symmetry. We have agreed upon that a line of symmetry will divide any geometrical figure into two congruent parts, which means that the corresponding sides are equal in length and the corresponding angles are equal in measure. Thus, if he asks you that AB is equal what here? Look at the figure. AB is equal, right, AD. What about DC? Also look at the figure. DC here is equal to, right, BC. What about the measure of angle ADC? Where is ADC? The angle ADC, yes, it's here. It's equal to the angle, right, ABC. It's corresponding one, ABC. Our line of symmetry will divide this figure into, right, into two congruent triangles. Thus, triangle ABC is congruent to the triangle ADC. Now let's move to another example. In the opposite figure, A, B, C, D. The dashed line, the red one, which intersect side BC in point Y and intersect side AD in point X. This line is a line of symmetry and AD is equal 6 centimeters. Also, YC is equal 5 centimeters and BA is equal 4 centimeters. Complete the following. Number 1. Angle B is congruent to, look at the figure. Where is angle B? Right. It's congruent to, excellent, angle C. Number 2. BY is equal what? Look at your figure. BY here is equal to, excellent, CY. Equal how many centimeters? 5 centimeters. Number 3. XD equal what? Look at your figure. Where is XD? Right. Equal, excellent, XA. But I don't have how many centimeters is XD. But it's given in your example that AD is equal 6 centimeters. And I know that a line of symmetry will divide AD into two equal parts, which means that XD is half of AD and XA is half of AD, because both of them is equal to each other because of the line of symmetry, which means that XD is equal, excellent, 3 centimeters, the half of 6 centimeters. Number 4. The perimeter of the figure ABCD. We know before that the perimeter of any geometrical figure is the sum of its side length. Thus, the perimeter of the figure ABCD is equal to the sum of AB length plus BC length plus CD length and AD length. Okay, let's now substitute. AB is equal what? From the figure it equal 4 plus BC equal what? Where is BC? BC is consists of YC plus YB. YC is equal YB. YC equal 5 and YB is equal 5. 5 plus 5 is 10. So BC is equal what? Equal 10 plus CD. We know that CD is equal BA, which means that CD is equal 4 plus AD is given. In our example, it's equal 6. The result will be 24 centimeters. Now open school book page 57, exercise number 1. Put true for the correct statement and wrong for the incorrect one, and correct the wrong statement. Letter A. The parallelogram has 4 lines of symmetry. False. It's wrong statement. Let's correct it. It has no lines of symmetry. Letter B. The rectangle has 4 lines of symmetry. False. The rectangle has 2 lines of symmetry. Letter C. The scale and triangle has 3 lines of symmetry. Also, it is wrong statement. Let's correct it. The scale and triangle has no lines of symmetry. Letter D. The isosceles trapezium has 1 line of symmetry. It's true. Letter E. The square has 4 lines of symmetry. Also, it's true statement. Last one. The rhombus has 4 lines of symmetry. It's false. Let's correct it. The rhombus has 2 lines of symmetry. Our homework, booklet page 37 and 38 and 39.